Hi folks, previously we looked at the binomial distribution, and that's when we had a certain probability and a fixed number of trials or events, whatever you want to call them. So that's what we're saying here. So we're going to change this here. So I'm just going to give a question right away, just so we can get a little scenario and then explain why it might be a little different from the binomial distribution. So here, I'm saying 5 taxis on average will turn up at a taxi rank in a certain time period. They're saying it's 15 minutes and they're saying it's on a Friday night. Why have they chosen a Friday night? Well, maybe there'll be fewer taxis on average turn up on a Tuesday night. So that's why they have to specify Friday night and a 15-minute period. Because in a 5-minute period, also there might be fewer taxis on average turn up. That's the magic word, average, throughout this. And you see throughout all the distributions that we look at, binomial, Poisson, and normal, average is very important here for us. And we need to have this time frame specified, about 15 minutes. Okay. Again, the type of average we're talking about here is a thing called the mean. And that's not arithmetic. We refer to that as the arithmetic average. So, for instance, just as a wee reminder, so say you've got so many students in a class and you wanted to work out the average age, you'd probably take all their ages to the nearest, to the whole year, add all those years together and divide by how many students are in the class. And that would be your arithmetic average, which we refer to as the mean. So I'm sure you're familiar with that. If not, go back and look at my basic statistics notes that I've sent you out. Okay, that's your job. Right, let's proceed. Previously, when we looked at binomial distribution, part of the formula used something was n choose r. And it's r I'm talking about here. Why did we choose the letter r? R was a thing we wanted to happen. A number of things, either exact or more than. The reason we selected that is because a calculator, most calculators use R to pay our number of interest. So I thought I'd just show you that because I'm going to change things. We're going to go back to the old favourite letter in mathematics for the unknown. It's something that we want to find. And we're going to refer to that as X. So here's the Poisson distribution formula. You can find out what Poisson means. Okay. In the formula, P in relation to X, P doesn't stand for Poisson in the formula there. Okay, so we've got various symbols there. So we're just going to go through them, just so everybody understands what's going on. So the mean, we just spoke about that, the arithmetic average. But we use a funny symbol for it. It looks like a U, but it's kind of got this a tail to the front or a big long bit of hair. That's actually what we refer to as arithmetic average, the mean, but it's the Greek letter, and well, some people pronounce it as mu. Sometimes if you had it in the English language, you choose like mu, even though I don't think that's right. I think the enunciation of it is like a wee cow saying moo, or moo. Okay, so that letter there for us, for the mean, is mu. Okay, now let's go back. So X, that's the thing or things we're interested in. So favourable outcome or outcomes. Okay, what else is happening in that formula there? E, well, E for us, that's just a number. That number is, well, it's just a little bit less than 3. Okay, you can see it there, 2.7182818284005. Okay, it goes on forever. It doesn't have a repeating pattern there. It's very similar to pi. 'Cause pi is just a little bit bigger than 3. 3.14159265535. So just like pi, E is a number. It's a fixed number. Okay? So we're using E, this letter here, to represent this fixed number. And it's sometimes referred to as Euler's constant. That's not Euler's constant, it's Euler's constant. Euler was a very famous mathematician. He actually had 13 children. And a lot of them were very clever. Anyway, let's get back to the formula. What else is in there? Exclamation mark. We saw that before in binomial. X factorial. We did see that. And in binomial, we said we'll not go on about this because it's going to appear here. So apart from the mean and X, we need to talk about E and X factorial, because for us, they're calculator functions or buttons. So X factorial, X with exclamation mark. So we've seen previously a little numerical example here. 4 factorial, that just means 4 times 3 times 2 times 1. And I'm sure when you do the arithmetic there, and the multiplications, you get 24. I hope. Yeah, we do. Okay. But anyway, we're going to use a calculator to deal with that. So on the calculator, it's actually on the back plate. But see the little button, x to the minus 1, x to the power minus 1. That doesn't mean x to the power minus 1. It means, well, it kind of does. 1 over x. But it's a thing that's above it here. That's that wee x factorial. So how do we locate it? Well, for us to locate it in the calculator, what we need to do is anytime a function or process, something we need on the calculator, if it's on the back plate, you usually need to press shift. Okay. Press shift, then press that x with a wee minus 1, and that will give you that wee x factorial button there. So I'm just showing you here, what if it was 6 factorial? So we would just go back there. And what you would do is put in 6 first, okay? Then press shift, okay? Then go to the next one and hit the x with a wee minus 1. And that will bring up that on your calculator. So that there, 6 factorial, if we did it long way, that'd be 6 times 5 times 4 times 3 times 2 times 1. And 6 times 5 would be 30, times 4 is 120, times 3 is 360, times 2 is 720, times 1 doesn't change it, so it should still be 720. So let's see, what does the computer say? It does indeed say 720. So use a calculator so we don't have to do all those multiplications. Okay, right, E. As stated earlier, that's just a number for us. Just like pi is a number for us. Natural exponential constant, Euler's constant, whatever you want to say. It's a number. Where is it in the calculator? There it is. You'll have a little button that actually says ln. That doesn't say in, and we read it backwards at NL, natural logarithm. But we'll speak about that in another class. It's the thing that's above it that we're interested in. So there's the ln button. It's the thing above it. E to the power. Okay, that number 2.7 a bit to a power. We're interested in that. So in order to activate that, again, you press the shift because that button was on the back plate. Then you hit ln, and then that will provide you with e to the power. And you're just going to put in a number there. So if it was e to the power, say, -2, like that there, what you would do, you just go back to that, and this time you do hit shift first, hit ln, e will come up in your calculator, and then that example there, just hit -2. And so once you do that, remember, hit equals, and what are we going to get? 0.135 and some little bits. That seems fine. But it doesn't matter about that result there, folks. It's how you locate it, how you locate that function we call e. And it's just a number to a power, because e is just a number, 2.7 and a bit. Okay, let's go back to that question there about those 5 taxis on average turn up at a taxi rank in any given 15-minute period on a Friday night. Okay, so that's information there. So here's a question. What would be the probability that exactly 4 taxis would turn up at the rank in any given 15-minute period on a Friday night? Is it any given Friday night? Who knows? So here the important thing, and the good thing is, we like exactly. And it's exactly 4. But exactly means there's only going to be one calculation. So exactly 4 taxis. Right. So the average up here is 5, so that's the mean. And exactly 4, that's going to be our x value. So that's why we're taking it here. So the mean is 5, on average 5 taxis. But we want specifically to look at 4 taxis turning up in this time period. So that's why x equals 4. Let's get the formula. Okay. You can see that mu appears on 2 occasions and x appears on 2 occasions. The other 2 parts, e and the factorial, that's the calculator's job. Numbers in. They're in, okay. Type it into your calculator to work out the probability of exactly 4. And what does the calculator say? Oh, and I've bracketed it up for safety, just in case, before I divide it by 4 factorial. I don't always do that, right? But it's good practice to do it. So what we're going to get, 0.17547. So what is that number? 0.175. You could write that. That would be your answer. That's the probability. But you might want to get a handle on that number. What's that? We might want to round it even more rougher than that. I've even went to one decimal place, 0.2, because I recognise that as a fifth. So I've done that because I can get a better handle on a fifth. So that means there's a kind of 1 in 5 chance here of actually 4 taxis coming up. Oh, wait a minute. Have you spotted the mistake? What's the big mistake here? Oh, there you go. 1 in 5 chance. I can't spell chance, but I pointed it out to you. I'm only human. Right, so there's a 1 in 5 chance of exactly 4 taxis turning up in that 15-minute period. Right, you can change that yourself. I'm using a mouse here, recording this in my house, in my recording studio. So I'll get rid of that. So that was a nice exactly question. So let's move on. Same scenario, on average 5 taxis. Right, same scenario. So let's go and get another question. So what would be the probability that this time 2 or less taxis arrived? Right, 2 or less. It's not exactly, so 2 or less. That means we're going to have more than just one calculation. We've seen that before in binomial. 2 or less. What does 2 or less mean? Well, 2 is included and 1's included. Right, so is that it? Just 2 and 1? But what if no taxis turned up? And I know you've been waiting on a taxi rank and a taxi has not turned up. So we're going to include 0 here. So I've just highlighted that 5 here because the mean's going to stay the same. So, and the notation I'm going to use here, probability P, T for taxis, less than or equal to 2. Less than or, that or word, we need to focus on that, less than or equal to 2. So that means probability of 0, probability of 1, and probability of 2. Right, and you can see there, the mean does not change throughout here. Means 5, but we've got 3 values that we are going to evaluate here in our formula, 0, 1, and 2. Okay, and I've taken a little shortcut here, and I shouldn't have done. I should have used the formula here, but you'll see in the next few examples, the formula is mu to the power x times e to the negative mu divided by x factorial, but you can look back and see that. So I'm just working out the 3 probabilities here. Probability 0, probability 1, probability 2. Sum them up, add them up, and we'll see what we get. 0.12465. So the probability that 2 or less taxis will turn up is that value there, 0.12465. But to get a better handle on that, I might round up again to 0.125. The reason I've done that is because I know that decimal is exactly equivalent to 1/8, which is nicer. I like that. So 1/8 in terms of the taxis means there is a 1 in 8 chance of a taxi turning up in that 15-minute period, or sorry, 2 or less. So that's what they're saying there, and I'll just scroll down there, and so that's what they're saying there. So there's a 1 in 8 chance of 2 or less taxis arriving at the rank. Oh, and did you notice? Did you notice? I could actually spell chance correctly there. That's okay. So I'll just get rid of that. Right. So are we going to move on from there? Are we kind of happy with that? I'm sort of happy with that. So in that question there, we had an exactly one and a less or more one, and that was a less than. Whether it's less or more than, what it means is if it's less or more than, there's more than one calculation. But we like exactly questions. Okay, I think I'm going to have a breather there. Right, I'm going to leave it there. So this is our first video from the extract from the lesson. Okay, So I'll probably do maybe another two, where there'll be little twists and turns along the way. So I think we'll do that. So let's see how this turns out. So I'll see you in a little bit, folks, okay? Right, and remember, you can always rewind these little videos and get in touch with me, especially if you can't understand me. Right, anyway, take care for now. Bye.